Hey guys, what's up? If you remember last time I was doing a topic from electrochemistry. So right now I'm taking the next topic from the electrochemistry. What so far I've done in electrochemistry was what is galvanic cell, what are cell potential, how cell potential are determined using standard hydrogen electrode, and also what are the Nernst equation. So this video is going to be the next topic, and this is going to be about changing Gibbs energy during a chemical reaction. And in another part, I'll be doing the relationship between cell potential and equilibrium constant. So let's do that because I don't think you have enough time to waste talking trash. So the topic I'm taking right now is change in Gibbs energy during cell reaction. So this is what the topic I am taking first. Let's start with the basic we have. If you remember, we had this galvanic cell. I'm not taking every part of that. I'm just repeating in very short. So this one represented zinc undergoing oxidation, and this one represented copper undergoing reduction. And the cell potential here was 1.1 volt. Right? And this was your oxidation half. And this one was your reduction half. Okay. So I have to, so what I need to tell you is that there are two types of cell we use in our day-to-day life. One is called, chargeable cell, other is non-rechargeable. So in a rechargeable cell, what happens? You have to apply some external power in order to get it charged. But in a normal cell which cannot be recharged, what happens? You start using it, there's some reaction taking place, and after a certain period of time, the battery or the cell become dead and you have to throw it off. So there are two types of reaction in a cell. So this is what, there is one called, charging reaction. Charging is a, non-spontaneous process. It's a non-spontaneous, and for this delta G must be positive. Then there is another reaction, discharging here. Another reaction is discharging, and discharging is a spontaneous reaction. You don't have to do anything in order to get a battery discharge. It will discharge on its own even if you don't use it. So this is spontaneous. And for that, delta G must be negative. Right? So the question is, how do we get to know how delta G is calculated? So delta G is calculated by NFE cell. Right? What N is? N is, number of electron involved in a redox reaction. In a redox reaction per mole of oxidation or reduction. So N is the number of electrons. So what N is here? 2. If you remember, there was 2 electrons involved in case of zinc and copper. So for that case, N is going to be 2. What F is? This was about N. What F is? F is called Faraday constant. Faraday constant, and this constant value is 96500 Coulomb. The actual value is 96487, but that's what we don't use. We use it 96500. And what this one is, you do know, this is the cell potential. Cell potential. And its value sorry for a second. Okay, so sorry for this little disturbance again. So E cell represent to the cell potential, and its value depends on type of, depends on oxidation and reduction species. Oxidation and reduction chemical species. Right? So every spontaneous process, delta G is calculated by NFE. That is negative value, because G must be negative for spontaneous process. Right? And for this one, delta G can be calculated by NFE, which should be positive, because this is a non-spontaneous process. So this is what the thing is about, Gibbs energy change during a chemical reaction. I hope you have understand. But so with that, I would say thanks for watching. And one more request here, like most of the YouTuber has to do, is if in case you haven't subscribed, this is your first time, do subscribe, hit the bell icon so that you get notification about everything I try to, make based on your requirement. So that's it. Thanks for watching.